how blockchain works. So what do you think how a blockchain transaction works? So we'll see over here, there is a user A and there is a user B. The user A wants to send 10 coins to user B and a transaction fee is set by the sender. Okay, so this 10 coins should go to B. So now what happens? A request is broadcasted to the network to pre-confirm the transaction. So now what happens? This transaction is first broadcasted to the network to pre-confirm the transaction. That means it should be verified first. So everybody checks that if user A has 10 coins or not. If yes, then only this will get verified. Once the data is confirmed, the transaction is placed in a memory pool. Memory pool is basically a memory stack in which there are all these transactions coming in, which are validated, okay, for further computation process. Now the main thing, mining. The mining process is when miners use the power and capacity of their nodes to make a block. This will be taught next. And when this mining process is done, a block is created and this block goes into the blockchain and it is broadcasted to every node on the blockchain, and then the user A gets this coin to B. Okay, mining process. Okay, so first we'll see what is double spending. Double spending means this is a buyer. Okay, he has bought something from seller A and seller B, so he has to pay them money. Now what he does, he has a total of 50 coins in his wallet. Now what he does, he sends seller A 50 and seller B 50 at the same time. So he sends 50 coins to seller A and 50 coins to seller B at the same time. This is known as double spending, and this is a huge problem in the previous bank accounts and all. It used to be a huge problem. So now this can be solved by this mining and all processes. So what is mining? Mining is basically adding blocks to the blockchain. On successful addition of a block, the miner or who has mined this block will get incentive. So a miner, what does a miner do? A miner has to solve difficult mathematical problems using his computational power. This can be any type of mathematical problem which will be told next. They take transactions from the mining pool. The mining pool is where all the transactions are put and validated by checking for double spending. They first validated, okay, is double spending has been done or not. How can they check? They can check it by taking one transaction at a time so that no double spending can be seen. If there is a double spending, he takes the first transaction and next transaction will be the same money that he has already sent. So the buyer's account will show 0, but it will show the transaction is from he has sent $50 though he had only $0. So this transaction, the other transaction will get failed. Okay. So now they then add the transactions to a block. So all the valid transactions which hasn't done double spending are put into the block. And how they are put? They are put by the use of Merkle tree. And in the block there will be the Merkle root hash in the block header, and all the list of transactions will be added to the block body. Difficulty. What is difficulty? Difficulty is hashing rate of blockchain divided by hashing rate for the target block coming through the miners. Okay, so difficulty is like there is a preconception that in Bitcoin basically every block should be added in 10 minutes. So if the miners are very easily adding the blocks before 10 minutes. So then they will increase the difficulty. And if the miner takes more than 10 minutes for this process, then the difficulty will be decreased by the blockchain protocol itself. So how does this work? So there will be the hash of the blocks. So hash of each block starts with leading zeros. You can see there are some leading zeros in the hash out here. So this is the total hash, this is the leading zeros. So leading zeros is the difficulty. So for this we introduce a new concept, that is nonce. Nonce is number only used once. This is a very simple random number which when combined with the hash of the block will give the starting strings with zeros equal to the difficulty. So the difficulty has told that these many zeros should be there, and this nonce is just a simple number. When hashed with the hash of the block together combined, it will give the new hash which will have preceding string of zeros equal to the number of difficulty. Now next, consensus. A consensus mechanism is a fault tolerant mechanism that is used in a computer and blockchain systems to achieve the necessary agreement on a single data value or a single state of the network among distributed processes or multi-agent system such as cryptocurrency. So what is consensus? Consensus you can think of as voting, where the majority wins. So in the blockchain network, we can see if more than 51% of the nodes agree to a particular block, then only it will get accepted, otherwise not. So if there are faulty nodes who try to put in some blocks, random blocks, and agree to them, they cannot do it because they need at least 50% of people to say yes for the confirmation of their block. POW, the POW consensus algorithm, basically the proof of work. Make sure that miners are only able to validate a new block of transactions. So in this consensus, what happens? The consensus is based on proof of work. It shows that a miner has done a lot of work and computational power to solve a particular hash to get the difficulty and the nonce with it. So it shows that their nodes have worked a lot to get this hash of the block. So and the people make the agreement and it is agreed upon the work he has done. Longest chain rule. The longest chain rule is what individual nodes accept as a valid version of the blockchain. The rule that nodes adopt the longest chain of blocks allows every node of the network to agree on that the blockchain looks like, and therefore agree on the same transaction history. So there is an example. See, first block 1 is created out here. Next, this block 1 is broadcasted to everybody. Now there are people who will start creating the block 2 based on the previous hash of block 1. Next, there can also be people who starts creating another block. There can be a possibility that two miners have created at almost the same time two blocks, the block 2 and the block 4. So now what happens? Now the next set of miners will see block 2 and they will start working on this block to mine this block. Some will see block 4 and they'll start working on this block, and some will see the block 4 again and start working on this block. So there is a possibility that there are many blocks created in the same chain. Okay, so now what happens? Now this shows that now the miners will see that there is another block creation and there is another block creation. Now it is based on which set of miners will go for which block. So if more than 70% of the miners go for this block and only 10% go for this block and rest 20 will go for this block, so what happens? This block will have more chances of getting mined as the next block. So this next block is mined by almost 70% of the people. So there is a high chance of the miner finding out the block. And then this is only by 10%, so there is less chances of that block being mined. And it is done by 20%, so okay, there might be a chance of having this block done. Next, what happens? Many more miners see this block, and this chain will continue growing on. So this longest chain rule states that the blockchain will adopt the longest chain, or the chain which is more worked upon. This block 9 will be left alone and will come out of the main chain. So there is ultimately there is a chance that when more and more people are contributing on the same chain, it will outwin the other chains.